1. Bzzz, what is electricity? Let's learn about electricity at the Children's Science Museum of the Busan National Science Museum. This is an exhibit called How is Electricity Connected? This gives you an idea of how electricity is connected and how it flows. So, what do these pictures have in common? Yes, all of these things use electricity. The home appliances that we use in our daily lives, such as televisions, refrigerators, and washing machines, can only be used when there is electricity. In this modern world, electricity plays an important role in making our lives convenient. So, what is electricity? Electricity is the energy produced by the movement of electrons. Just like the S and N poles of a magnet, where the same poles push against each other and the different poles pull against each other, there are two types of electricity: positive and negative charges. A negative charge is also known as an electron. Like a magnet, electricity has the property that the same charges repel each other, and the different charges attract each other. Positive charges do not move, but negative charges, that is, the charge, move very freely. This negative charge, or electrons moving around, is what creates electricity. As I told you earlier, when electrons move, they create electricity. This constant flow of electricity from the positive pole to the negative pole is called the current. Now, let's make a connection from the positive pole to the negative pole so that the current flows. Even though electricity is invisible to us, bright lights let us know that it's flowing. If we connect the positive and negative poles correctly, the LED lights up and we can see a holographic image. And a path through which current flows is called a conducting wire. But is it possible for us to use any material as a conductor? It isn't. Current flows well in some materials and not in others. Materials through which current flows well are called conductors, and those through which current does not flow well are called non-conductors. This is because electrons and atoms can move freely through conductors, through which current flows well, and electrons and atoms cannot move freely through non-conductors, through which current does not flow well. If you want to use a conducting wire, you need to use a conductor, a material through which current flows well. So let's first find out which of these things here are conductors through which electricity flows well and which are non-conductors through which it does not. Then, let's make a conductor-non-conductor discriminator, Dr. Electric, to see if we've correctly divided the conductors and non-conductors. Connect the red and black wires to the fairy light bulb socket and fix them. Then connect the red wire to the positive part of the battery holder and fix them. Insert the battery into the battery holder. Connect the battery holder to the fairy light bulb with the black wire. Use an awl to punch holes on both sides of the transparent cup. Put the holder with the battery inside the transparent cup and pull out the red wire through both sides. Put a straw cut into 2 cm pieces on the red wire on both sides to make arms and clip both ends. Put eye stickers on this. Connect the clip and see if the fairy light bulb turns on. First, let's check to see if they light up through the conductors. All of the fairy light bulbs turned on. Since current does not flow through a non-conductor, the fairy light bulbs won't turn on. Want to check it out? We correctly divided conductors and non-conductors. Visit the Children's Science Museum at the Busan National Science Museum, where you can experience electricity through various play activities.